Hello everybody, welcome back. Today we're looking at example 3 from 7.5. It says solve a quadratic equation with only one root. So again, we're factoring. So remember, when we factor, what we need to do is we want to make sure that we take a look at it and sometimes look for some of those specialty polynomials. So you may recall from last year, or hopefully you recall from last year, that sometimes you have what's called a specialty polynomial. So in this case, this is what's called a perfect square trinomial. It's interesting. And again, this can be done with decomposition if you didn't identify that that's what it was. But I recognize that the first term, the x squared term, is a perfect square. That would be 2x. I recognize that the c value, the plus 47, is a perfect square. Take the square root of, 49, I apologize. Take the square root of 49 and you get 7. So if I take the 2x, multiply it by the 7, I get 14x, and I double it, I get the b value. That is what's called a specialty polynomial. Okay? And when I factor that, I get a polynomial that looks like this. 2x plus 7, 2x, 2x plus 7 equal to 0. All right? And that's why there's only one root, because they're the same, right? So it's technically, it's called a touch. It comes down and touches the graph at that. So all we need to do is take one of these and set them equal to 0, because they're equivalent, so you just got to do it once. Subtract the 7 from both sides. Subtract 7 will give you 0, right? 2x plus 0, 0. Subtract 7 from here. And then obviously divide both sides by 2. Dividing that by 2 leaves you with x. Divide this by 2. Then you get negative 3.5 or negative 7/2. Okay? And again, you can, I don't mind this one, we can say this, or negative 3.5, because it is a terminating decimal. I know some of you like to have them as decimals. Again, if it is a terminating decimal, like in this case, that's okay. And verifying the solutions like we did yesterday, so to verify, take the original, all right, we're going to verify. So what we do is we let x equal 3.5. So everywhere we see 3.5, we're going to put in our x value. So we substitute our x value in for 3.5, right? And we're going to square that. So when we square that, we get, squaring this, we get 12.25. And make sure you don't forget your bracket there. Okay, 12.25. Multiply 28 by 3.5, and we get, oh, so this was negative, my apologies. Put the negative in there. So we multiply, we get negative 98, and then the 49. We multiply 4 by 12.25, we get 49. And 49 plus the 49 will give you 98, obviously. So 98 subtract 98, and 0 is equal to 0. So that just confirms that our answer is correct. All right? You don't have to do that often, but it's just a way to show if you're doing it algebraically, you got it correct. Okay? So the roots are x equal to negative 7.5, or as a decimal, negative 3.5. Okay? Next example, we have example 4. Use reasoning to write an equation from its roots. So as Tori says, she solved an equation by graphing. She says the roots were negative 5 and 7. How can you determine an equation that she might have solved? So you just kind of go backwards, all right? So we know, based on the information given in the question, we know the roots are x equal to -5, and x equal to 7. So we know that information. All right. So we can use what's called the form of the quadratic. We can use factor form, right? So we know that y is equal to and we have an a value. Not that we have to solve for it here. So a minus the first root, we call it r, and x minus the first root, we call r, and that's when we call s. We talked about that earlier on. Okay. And again, we can just have the a value as 1 because it just said any equation. It could be any equation. So we put in the first one is -5, and the second one is 7. The root. So s is the second root 7, right? And we'll clean this up. So x subtract the -5 is just x plus 5, right? Subtracting a negative is just adding. And that's the factor form. That's the factor form. And then we're going to put it in. And now this is not the only equation. This is just a possible equation. Remember we had that a value. We just made the a value 1, right? And let a equal to 1. And we can do that here because it said an equation, right? Because it said an equation. So we didn't have to solve this because we didn't have another point. So to get the general form, or standard form, okay, and we're just going to multiply this. So we have x times x plus x times -7 plus 5 times x plus 5 times -7. So that's what we did in grade 10. We're using what's called the distributive property to get the general form. Clean it up. X times x is obviously x squared. -7 times x is -7x. 5 times x is 5x. And 5 times -7 is -35. The two terms in the middle are like terms, so we can add them together. So we end up with -2x minus 35, and that is the general form of the quadratic here, of this parabola. Okay? And then the last example, example number 5, says, describe any errors in the solution. Matthew solved the quadratic equation as shown. Identify and correct any of the errors. So when you look at this, Matthew divided by x, which ended up with 4x equal to 9, right? And then divided by 4 and got x equal to 2.5. Now, that looks like it's true. However, you can't divide by x here, because what if x was 0? And you can't divide by 0. So it's really interesting equation here. So I'm going to show you the proper way to identify that. And again, remember what unit we're dealing with here. We're talking about factoring. So yeah, you guessed it, we're going to have to factor. I'm going to show you what x is going to be equal to, because there's two values that you can have here for x. All right. So what we'll do is we'll subtract the 9x from both sides. In doing so, we get 4x minus 9x. So I subtract the 9x from both sides to get this, right? And then we're going to factor out an x. So when I factor out an x here, I end up with 4x minus 9. Okay, so this is actually considered two factors. So now I have to let both factors equal 0. So x equal to 0 and 4x minus 9 equal to 0. So x is equal to 0 on this side. I add the 9 to both sides. I get 4x equal to 9. Divide both sides by 4. 4 x divided by 4 is that. And I get 9/4. Or you can say x is equal to 2 decimals to 5. So they weren't completely wrong, but you can't divide by x here. And the reason is because you could get x equal to 0. And obviously if you divide by 0, it's all right. So pretty good. I wouldn't get too wrapped up with that. Like, it was a good starting point. But remember, we were dealing with factoring, and this is the proper way to show that. X can be equal to 0, and x can be equal to 9/4, or as a decimal, 2 decimals to 5. So what you're going to do now is you're going to try some of the questions on page 405, 1 through 11, 13 through 15, and 17 through 18. Thanks for watching, everyone, and we'll talk again soon.